So far we have seen various techniques using which we can say a particular number is a valid perfect square or not. Now let's quickly write the binary search based algorithm that we have discussed, right? Let's write the Java based implementation for the same thing. So here whatever I have basically created the new file called is valid perfect square. In that I have added main method as well as the method that we will be implementing. Here the return type of the function will be boolean to return true or false based on if this number is a perfect square or not. So ultimately here we will be using the binary searching algorithm that we have discussed previously, right? That based solution we will be writing here. So here as part of the first couple of checks, what we will do is, if at all this number that is being given by the user, right? If at all if this number is less than 0, obviously it will not be a valid square because the perfect squared numbers will never be less than 0. So in that case we will simply return -1. Okay, -1 in the sense we will simply return false. I am used to solving the array problems where if at all the index is not available, we will return -1, right? That's the reason why by mistakenly said -1. But anyway, if that is not the case, if at all the value that number that user has passed is equal to 1, or if the number is equal to 0, in that case obviously it is a valid square, right? Because 0 square is 0 and 1 square is obviously 1. In this case what we will do is we will simply return true. Okay, so if user passes any other value, then we need to write the binary search based solution for the checking of if a number is particular valid square or not. So for that I am going to define one variable start, and this I am going to initialize it with 1, and similarly I am going to define another variable end. This I am going to initialize it with num. Remember that the square of a number will never go, obviously it will never go more than n by 2, but here the end whatever that we have defined, this I am going to initialize it with the number that user has passed. Similarly I am going to define one variable middle, and this I am going to initialize it with -1. Now what we will do, we will simply run a loop as long as this start is less than or equal to end. What we will do, we will calculate the middle. Middle is nothing but start plus end divided by 2. Okay, once we calculate the middle, what we will do, we will check the square of the middle. That means middle multiplied by middle is equal to number or what. If it is equal to number, obviously it is a valid square, right? In that case we will simply return true here itself. Okay, that is as simple as it is. We have a start value, we have an end value, we have calculated the middle. If this middle is matching with the value that if this middle multiplied by middle is giving the number that user has passed, we will simply return true itself because it is a valid square value. If this is not the case, the other scenarios are, if this middle multiplied by middle, if it is greater than whatever the number that you have been given, in that case the squared value is greater than the number given. That means the number is smaller. That means it will be there on the left part of the array. For that what we will do, we will update the end with middle -1. If this is not the case, that means the value that we have been given is greater than the middle multiplied by middle. That means it will be there on the right part of the array. To continue the search on the right part of the array, we will simply update the start with middle +1. Okay, here once we are done with checking of all the possible values for checking if a particular given number is valid square or not, if we exhaust this condition, basically we will come out of this loop, right? In that case basically the value whatever we have been given is not a valid perfect square. In that case we will simply return false here. Okay, it is as simple as that. Okay, if at all if you wanted to use a naive based brute force solution, what you will do, basically you will start iterating from 0 to the number whatever we have been given. You will multiply that value with that value itself and check if that value is matching with number. But rather we can simply eliminate a lot of other comparisons by simply using the binary search based solution like we have discussed here. Okay, now let's just try to call this function and validate. Let's just say I want to search for the number, let's just say 16. And to call this valid perfect square using binary search, first we need to create the object of this. So let me just create this, and let's just directly print the value by calling vs dot is valid perfect square, and let's just pass the number to it. If you see, we have passed 16, right? 16 is nothing but a valid perfect square because 4 square is 16. So if I run this right now, the output should be true. So that is what we have got here as well. Okay, so let me just expand it. Let's just say I want to search the value, check if 1 is valid perfect square or not. So if I run this right now, we have got true as well because 1 square is 1. Let's just say I want to search for the value 15. 15 is not a valid square, right? So we got false. Okay, similarly, if I pass any negative value, we should get false itself because it is not a valid square. Okay, so all the test cases are basically passing. So that is how we check if a particular number is a valid perfect square or not using binary search. If at all, if you want the code for naive brute force approach, you can check out codingpal.org specific to this problem by using the link in the description, so that you can check out that code as well if at all, if you want to give it a shot. Okay, so that's it for this one. I'll see you in the next problem.